Today's heading drift velocity. Drift velocity of electrons. Drift velocity of electrons denoted by the symbol V D. What is drift velocity of electrons? You can write down definition, then we'll derive a formula for it. That the average definition, very often they ask on that, listen, drift velocity of electron. The average velocity, acquired by the electrons, in the direction opposite to the electric field is called the drift velocity of electrons. Okay, you have to understand the concept of this. So for that we will be drawing this diagram. We will take a conductor here and we will have electrons. These are the electrons, and atoms are there like this way. The atoms of the conductor are there. Fixed atoms are there. So many electrons and so many fixed atoms are there. And now, actually what happens, when we don't apply any electric field here, electrons, these are free electrons, they are in motion, all the time they are in motion. But in random motion, they are in random motion in all possible directions. And as a result, we find that no electrons are flowing out of the conductor. That means the sum of the initial velocity of all the electrons is 0. That means we will be writing like this: u1 plus vector wise u2 plus u3 so on plus un equal to 0. Sum of the initial velocity of the electrons is all 0. This is the situation where we are having no electric field applied. Now, when we apply the electric field here, like this through a battery, which provides a voltage D, this is suppose positive, this is negative, you will find that electric field acts in the direction positive to negative. So, what is the direction of electric field? Electric field direction I will mark here like this E. And this positive will be attracting the electrons negative this way. So the electrons were having random velocity, now it will be drifted, it will be directed towards the positive terminal, somewhat like this way. That velocity I take as V1 and V2 and all. Now the electron will be directed towards the positive terminal of the source. That means electron is picking up the velocity. The velocity of the electron is, suppose first electron velocity is V1, second electron velocity is V2, third electron velocity is V3 and so on. What direction does it, the velocity is acquired by the electron? The direction is opposite to the electric field. That's what we say in the definition. So average of all such velocities is called drift velocity once we apply the electric field on it. So to find a formula of drift velocity, first we will be writing this equation of motion we follow. We will write V1 equal to V is equal to U plus AT formula we have that V1 is equal to U plus A. Acceleration is all the same because all pick up the constant acceleration. We had A, we will be writing as tau1. The time of acquiring the velocity V1, drifting and hitting the other atom is called time of relaxation. I will give the definition of time of relaxation later on. First I write like this. Here we will be writing a U1. And write vector wise like this way. A is vector here. Same way V2 will become like this. U2 A tau 2 V3 will come with the arrow mark, U3 plus A tau 3. Write A everywhere because acceleration, we are applying the same force on each electron and mass of the electron is all same, so they all acquire same acceleration. So on like this. For nth electron will be written as the same way, Vn equal to Un plus A tau n, where tau, each individual tau 1 is called time of relaxation. What is time of relaxation? Time taken by an electron, I'll give the proper definition later on, time taken by an electron to acquire the drift velocity from its initial velocity, from its initial random velocity. That time is called time of relaxation. Let us add all of these. We will be adding all of these. You get V1 plus V2 plus V3 like this, so on, plus Vn. When we add, it become like this, U1 plus U2 plus U3 dot plus Un together plus A, and here I am getting tau 1 plus tau 2 plus tau 3, so on, plus tau n like this. We are adding all the equations here. Answer of this we know already, we have written here, this is 0, this part is 0. So we will be getting like this, V1 plus V2 plus V3, so on, plus Vn is equal to A tau 1 plus tau 2 plus tau 3 and so on, tau n. After getting this, how to find average? Average means add all the velocity and divide by how many of them are there. So we will divide by, this thing will divide by n here also we will divide by n, both the sets. And you can make a note that dividing, after adding is dividing both sides by n. This is called average velocity of the electrons. That is only known as Vd. Vd will write as Vd with the arrow like this. And here I will be writing an A. Average, this is average relaxation time, that I denote by tau. Tau is called average relaxation time, which overall time of relaxation. So we are having the equation coming Vd is equal to A tau n. Now continuation of this will give the answer like this. Vd equal to acceleration formula, we have force upon mass. Here we are getting F by n into tau. Continuation of it is coming here. Okay, force. What is the formula of force? The formula of force is QE. And we are having electron. What is the force on the electron? E into E. So here the F value I will replace it right here. E into capital E by n into tau. And put the arrow here, but direction will be opposite here, minus, because force on the electron, this is pulling this way, whereas electron is acting this way. The minus sign is indicating that. Therefore we write there for magnitude of Vd, magnitude of this velocity will become like this. Vd, we are not taking minus sign, only magnitude, that is answer will become E by n into tau. Or we can write as E tau into n. So this is the relationship we are getting between, this is E tau by n. Vd is equal to E tau by n. This is a relationship between drift velocity and the electric field. Vector time will be writing a minus sign because this Vd and electric field are in opposite direction. You can check the definition now of the drift velocity. What is the definition I have given? The average velocity acquired by the electron in the direction opposite to the electric field is known as the drift velocity of electrons. Now you can write down the definition of time of relaxation. Right? Time of relaxation is the time between two successive collisions. Is the time between two successive collisions of the free electrons conductor with its atoms. So this is the relationship we get. But here this formula is simplified a little more, and now we will be writing like this. One step we'll go further from here. We'll be writing as Vd equal to, here we write mu into E like this. You can mention where mu is equal to E tau by m, and this mu is called mobility of electron. This mu is called mobility of electron. Now how to define mobility of electron? To define mobility of electron, the value of E we will put 1 unit, that is 1 volt per meter. Then Vd will be equal to mu. So mobility of electron, mobility is the word coming from motion. So how to define this mobility of electron? We say it is the drift velocity acquired by the electron. Definition of this you can write down. It is the drift velocity acquired by electrons when an electric field of 1 volt per meter is applied on it. The value here putting 1 volt per meter or 1 Newton per coulomb. When the electric field of 1 volt per meter is applied on it, that is the definition of mobility of electrons. Okay. Now give next heading. Relationship between drift velocity and the current. Relationship between the drift velocity and the current. Relationship between the drift velocity and the current. For that the diagram remains this only. The diagram does not change. The diagram will not change. It remains the same diagram. So now we write like this. Since I is equal to, first we write Q upon T. Charge upon time. We all know I is equal to charge upon time. Charges flowing upon time. Continuation. I, Q formula we have Ne. So write Ne by T. Ne by T. Here what we will do, where A is the number of electrons, so we will be dividing by volume. We will write this N divided by that here volume. Multiply also by volume into volume into E by T. So I will divide and multiply by the same quantity. Volume here also and volume there also. So number of N stands for number of electrons per unit volume, that will denote by small n. This is called concentration of electron. Into this volume formula I am writing an area of cross section into the length of the conductor. The total length of the conductor is L, suppose. Here I write L into E by time. Okay, now we will take this way. N, A, E will put together. N, A, E we are putting together. And L by T will see now. L is what? Length of the distance upon the time, total time from here till here of acquiring the drift velocity. L by T, distance upon time makes velocity, average velocity, that is Vd. So this is the formula we are having. Vd is equal to I by NAE or I is equal to NAE Vd. So this is the formula we have. This formula derivation may come. For that you will draw this diagram and you do this one, it will carry 3 marks. Previous one, what I did know, only definition of drift velocity and the definition of relaxation time is important. Though derivation I showed all that, how the drift velocity comes and the formula I showed, but that is less important. If you get time, then you concentrate on that heavily, otherwise you can see that portion lightly. But this is important, this derivation, the formula derivation is important. And we can continue and get one more formula. We know the fact that I by A is, let us make the subject become any Vd, and I by A is called J, so we can write here any Vd. So we have this formula, J is equal to NE Vd. In vector form, we can write as J is vector and any VD can be written any VD like this, because J is current upon area and current flows in the direction opposite to the direction of velocity. That's why a minus sign is given here. So we can write with the minus sign indicates the opposite direction here. Current density and then VD will be in the opposite direction. So a little further continuation of this we have done here. Okay. Now you can give next heading. Ohm's law in vector form. This is important. Ohm's law in vector form. Next heading is this. Ohm's law in vector form. Ohm's law in vector form. Ohm's law in general form we have V equal to IR. That we have done in class 10 also. But now Ohm's law in vector form is like this. I write the vector formulation. J is equal to sigma E, or J is equal to E upon rho, like this. This equation is called Ohm's law in vector form. If question comes for 1 mark, this question has come to twice or thrice in IIC in recent, 10 years time. You will find they are asking the question: express Ohm's law in vector form. Or write Ohm's law in vector form. So we just write this one. Either this way we write or that way. Any one way will express it. So J is equal to sigma E, or J is equal to E by rho. Rho means resistivity and J is the current density. Here sigma means conductivity. Remember that. This is all about the electricity. Ohm's law is dealing with the electric current. So sigma is the conductivity. How to prove this one? So proof. For deriving this derivation we do derivate, since J is equal to I by A. First let us write that J is equal to I upon A. Next time I is equal to, we will be writing V by R using the simple formula of Ohm's law, V by R. Now next continuation of this, write V as it is. R value we write rho L by A into A. This A and this A cancel. We get J is equal to voltage per unit length, V by L. Then volt per meter, that is called E. So we can write E by rho. If question they are asking to prove this, then here we will put arrow. The J and direction of E is same, so it will become Ohm's law. Or the same thing we can write like this: 1 by rho will become sigma, so sigma E. Or we write as J is equal to sigma E, this way. In vector form, the direction of J and the direction of electric field is the same, because J represents I upon A. So the direction of J is the direction of flow of current. So flow of current and electric field is in the same direction. So we will be writing the equation like this. Is the proof of Ohm's law in vector form. The question may carry either 2 or 3 marks, but this is important. Either they will ask just write the equation, or they will ask you to prove that J is equal to sigma E or J is equal to E upon rho. So we will be proving in this manner. Okay, then one more thing is there in the syllabus, but it has not come in ISC as yet. That also, but we will do it. Okay, you can give the heading Ohm's law. Next heading will be Ohm's law in terms of physical parameter, in terms of physical parameter. So for this we'll be starting from there. Since VD is equal to, as I have written already there, E tau upon n into E. This is for mobility. E tau by n is for mobility of electrons. We'll be writing this VD is equal to E tau by n into E. Okay, now VD is equal to, I'll be writing this I by NEA, because we know I equal to NEA VD. Therefore VD and make the subject become I by NEA, and here E tau by n keep as it is. This electric field are at volt per unit length. I write like this. Therefore I value will become cross multiplied, become that is n E square tau A by ml into V. So what do we see? We see that this thing is constant, therefore I is proportional to V. So this equation is called Ohm's law. This is called Ohm's law in terms of physical parameter. This equation is called Ohm's law. Ohm's law says that the current flowing is directly proportional to the voltage. More the voltage, more the current. Less the voltage, less the current. So this is only the Ohm's law. And this thing will be behaving as what? This thing will be the value of 1 upon R, because we had the formula I equal to V by R. So V divided by R, that is 1 by R value is this much. Therefore we can write, therefore 1 by R is equal to this value. N E squared tau A by ml. If you make R the subject of formula, the value of R will become just a reciprocal ml by N E squared tau and A. So this is the formula of resistance. And from this formula you can check out R is proportional to length and R is proportional to 1 upon A. That is inversely proportional to the area cross section. Last time when I told you that resistance is directly proportional to the length of the conductor, resistance is inversely proportional to the area cross section of the conductor, and it is justified, it is validated here by this equation. And R depends upon the nature, because nature will have the value of n. N is number of electrons per unit volume. N stands for, small n stands for number of electrons per unit volume of the conductor. And this one, R depends upon the temperature, because temperature affects the value of n. So this is the idea behind. So if you continue a little further, R is equal to, you can write rho L by A resistivity, and here also write ml by N E squared tau into A. L by A cancel. You get rho values coming, that is N divided by N E squared tau. This is the formula of resistivity. So check the formula of resistivity. In the formula of resistivity, do we have L and A coming here in this formula? Answer is no, because resistivity does not depend on the length and area cross section of the conductor. That's why resistivity formula is N divided by N E squared tau. The key point we have to begin from here. From here we will begin and then come to this. Ohm's law in terms of physical parameter, and the resistivity formula is this. If they are asking to find the formula of conductivity, sigma will be what? Reciprocal of this. Therefore we can write sigma is equal to reciprocal, that means the answer will become that is N E squared tau divided by N. This is the value of conductivity, or equation for conductivity is sigma is equal to N E squared tau by N. These all are there in the syllabus, but if you ask me which is important, because this is too much, the important thing is the definition of drift velocity of electron and the definition of time of fluctuation. Please learn them well. And the derivation of the first formula I is equal to NEA VD, and the Ohm's law in terms of Ohm's law in vector form are important. These are there but not very important. So these are there in the syllabus. That's why I did it. But they are not in the. They are not taken as important questions. So hope I think this is clear. This part is okay. Now we will be doing some problems, numerical problems from this chapter, and then next day we will be starting the circuits, electrical circuits. Okay, now you can take some questions. Now we will be discussing and we will be doing. Okay, now I read question. Question says, find out resistivity of a conductor. Find out resistivity of a conductor in which a current density of 2.5 ampere per meter square is found when an electric field of 15 volt per meter is applied on it. So I write on the information. They are saying current density with J value is 2.5 ampere per meter square is found, FOUND, found when an electric field of 15 volt per meter is applied on it. You have to find the value of resistivity. What is the formula connecting J and E? I am sure the formula goes like this. J is equal to sigma E. That is Ohm's law in vector form. But the question is asking about resistivity. We can add E by rho. Therefore, rho is the subject. We get E by J. Electric divided by current density. This is 15 divided by this value 2.5. The value of rho divided answer will become 6. 6 ohm meter. Unit is ohm meter. So we will be writing that. That is the question number 1's answer. So I already read the question. You can note it down in the slow motion and then work it out. Next question is, they are saying like this: a metallic wire has a resistance of 4 ohm. A metallic wire has a resistance of 4 ohm. If it is stretched into double its length, without changing its volume, what will be its new resistance? That is the question. I will explain to you the question and then we will be solving it. Question number 2. Question says there is a wire of resistance 4 ohm. That is initial resistance you can write as R1 value is 4 ohm. And the same wire we are stretching it to make the length double than before. What is the new resistance? They are saying that. So when you stretch a wire, the volume will not change. So you have to find R2 value. R2 value is unknown. So we write the formula is R1 by R2 is equal to, we can write the formula L1 by L2 whole square, you can write there, whole square. Don't write only L1 by L2 because when you, I'll tell you the reason behind it, but the formula becomes like this. And diameter wise or the area of cross section wise, the formula will become as A2 by A1 whole square, inversely proportional way. And diameter wise you can write like as D2 by D1 whole square. This way the relation will go on. When we keep the volume same or when we keep the mass of the wire same. But why this formula comes, I'll give you the reason later on. Okay, first we'll see the solution of this question. So question talking about the doubling the length, not the thickness and all, doubling the length. So we'll be following this part of the formula only, right? That is R1 by R2. Here we write L1 by L2 whole square. R1 is 4 ohm. R2 we have to find. Initial length we take as 1 unit, the new length is double. So write 2 square. What is the answer coming now? 4 by R2, this will become 1 by 4. The answer will be 16 ohm. Don't think the length is getting doubled, so resistance also will get doubled only. The answer will become 8. But here the problem is when you increase the length, area of cross section is decreasing because of stretching. When you stretch, it becomes thinner. So area of cross section is decreasing. So there will be another increase due to decrease in the area. That's why the formula becomes L1 by L2 whole square. So that is the reason behind. So the answer will come 16 ohm. It will not come 8 ohm. And the reason why the formula becomes like this, I will show you about that. You know the formula of resistivity, R is equal to formula where rho L1 by A1 we can add. This is the first step before stretching. R2 value will be writing as R L2 by A2. Resistivity is same because the wire is same, material is same. We will divide the two of them. R1 by R2 will be equal to, these two will cancel. Here we write L1 by L2 and here I will be writing opposite A2 by A1. Now see this one. Since volume is same before stretch and after stretch, and formula volume we have area cross section into the length. Here I am writing A1 L1 is equal to A2 L2. Make a L1 by L2 the subject of formula. It will become A2 by A1. So what I will do now, R1 by R2 is equal to L1 by L2 will keep as it is, and A2 by A1 when I will replace, I put L1 by L2. The answer will become R1 by R2 is equal to L1 by L2 whole square. That's what I wrote here. You can have a look at it. So this is the reason why the formula becomes like this. But exam time you may not show how this working directly. You can write in this manner. Like when you are stretching, the area of cross section is also changing. So the relation becomes like this. Now the relation why I wrote like this. Now you can see why I have written like this. R1 by R2 is equal to L1 by L2 is equal to what? A2 by A1. Let us put the value area wise A2 by A1 whole square. That's why the formula becomes like this, area of cross section wise. And thickness, what is the meaning of thickness? Thickness is diameter. So let us change it into thickness wise or diameter wise. A2 formula, area of cross section is like a circle. If it is a wire, so area of cross section will be circular. So what is the formula of area of circle? Pi r square. So here we will be writing pi r2 square pi. Power become 4 here. Diameter by the power should be 4. So be the correction here. Write power 4. And here write r1 square whole square. Pi and pi cancel. Here you get r1 by r2. Here write r2 by r1. Square and whole square is becoming, power is becoming 4. We will be writing here 4. So let us change diameter, multiply by 2, divide by 2, because you know twice the radius is equal to diameter. So 2r2 will make d2, 2r1 will make d1, power 4. This is answer. That means diameter wise the power become 4. Area wise we write opposite, because 1 will go with 2, 2 will go with 1 because they are inversely proportional. And power will remain square. But length wise, that proportion R1 will go with L1, R2 will go with L2, and the power remains square. Diameter wise or thickness wise, the power become 4, and then inversely proportional D2 by D1 will do. Okay, this question is answered. I think you know the logic also, but in exam time you may not express your logic, you may not show it. You can directly do like this. So I do another question. Question says, next question is here, if a copper wire is stretched, again stretching, if a copper wire is stretched to make it 0.1% longer, then what is the change in its resistance? Then what is the percentage change in its resistance? Question says that. What is the percentage change in its resistance? Again we are stretching and making the length 0.1% longer. So then we can write a relation right directly. We can write since R1 by R2 is equal to write L1 by L2 whole square. You can write here since volume of the wire does not change. Just make a note of this. Does not change. We will take initial resistance as 100% because question talking about percentage. R2 is unknown. Initial length we take as 100%. The new length is 100.1 because 0.1% longer, and the new length is 100.1 and the square of it. Find the value of R2 from this equation. Whatever is the value of R2 coming, I am sure the value of R2 will come 100.2 ohm will come. I guess. I am not very sure. You can do the calculation in calculator. Therefore, percentage change. Percentage change is increase. Percentage change is increase in resistance. Before it was 100, now it becomes 101.2. Therefore, change will be 0.2%. That is answer. Therefore, we may not be percentage sign here. Let us say change in resistance is equal to 0.2%. For the percentage change, we will take the initial value, base value will take as 100 and then we will calculate. Okay. So this question is solved. Now I read another question. We say like this: 1 kg of copper wire is drawn into 1 kg of copper wire is drawn into 1 millimeter thick and 2 millimeter thick wires. Compare their respective resistances. You are given 1 kg of copper and you are making two different types of wire. First wire's thickness should be 1 millimeter and the another wire thickness should be 2 millimeter. You have to compare their resistances. Which will be offering higher resistance? I am sure the thinner wire will be offering higher resistance and the thick wire will be offering lower resistance. But you have to give exact ratio. In what ratio? So what type of formula we follow here? We write R1 by R2. Here we thickness wise we write D2 by D1 to the power 4. Mind the power 4 here. You have to find ratio at R1 by R2. D2 is 2 millimeter second wire and this is 1 millimeter. Keep in millimeter both, millimeter cancels. You are finding ratio, the answer will come 16 by 1. The ratio is 16 is to 1. That is the answer. That means R2 value will be 1 by 16 times of R1. That means the second wire's resistance will be 1 by 16 times of the R1. If R1 value is given 32, then what is the value of R2? 1 by 16 into 32, the answer is 2 ohm. The second wire will be offering lesser resistance. So this is the answer for this question. Now one more question on this we will do, and then this chapter will be over. Question says a copper wire of diameter 1 millimeter. There is a copper wire of information diameter 1 millimeter, 1.0 mm. Carries a current of 1 ampere. Carries a current of 1 ampere. Its I value is 1 ampere. If there are 8 into 10 to the power 28 electrodes per meter cube. Per meter cube is per unit volume. That is small in values given. 8 into 10 to the power 28 electrons per meter cube. Per meter is per unit volume. In copper, estimate the drift velocity of electrons. Estimate the drift velocity. Drift velocity of electron, we know the formula since I is equal to NEA Vd. Therefore, Vd will be equal to I divided by NEA. Putting the value of current 1 ampere. N value I put 8 into 10 to the power 28. E means the charge of electron 1.6 into 10 to the minus 19. And area, since diameter is given, we change it into areas. Area will be pi r square. Pi r square. R square. Radius 1 millimeter is the diameter. The radius will be half of it, that is 0.5. We write 0.5, but millimeter must be changed into meter. That means 10 to the power of minus 3. And now you have to use calculator and calculate this answer. This answer will come something into 10 to the power of 3 will come. That is something millimeter. It will come in something millimeter per second. So I guess the answer will come something meter per unit will be meter per second. That exact answer I don't remember, so we have to calculate. So this is the solution for this question. And then we will do one more question. And the question is here. These are the types of questions which they had asked in the past in ISC. Next, to find temperature coefficient, that is, you have to find value alpha. Alpha is unknown. Resistance at 0 degrees Celsius is given 5 ohm. And at resistance at 0 is given 5 ohm. And resistance at 273 degrees Celsius, resistance at 273 degrees Celsius is given 10 ohm. You have to find the value of alpha from here. The formula of alpha goes on like this, no? Like R theta minus R0 upon R0 into theta, or changing the resistance per original resistance per degree rise of temperature. What is the change in the resistance? 10 minus 5, we write here 10 minus 5. R0 value is 5 into 273. This is 5 cancel, you get 1 by 273. Unit of alpha you can give per degree Celsius minus 1 or per Kelvin. So this is the solution for this. But this is also 1 year IC question. They had asked in the year 2016, I suppose. They had asked this question. So this type of question, simple question, but formula based from this chapter, right? Okay, then we do this much for the day. Next class on Monday, and then we will be doing the circuits out there. I mean, series combination, parallel combination, and power and all I talked about. Okay, and then slowly we will be reaching Kirchhoff's law. Okay, thank you for the day.